Good afternoon, this is Mr. Precella. Today we're going to be looking at rational and radical equations with our co-requisite college algebra class. And this is one of the longer lectures of the semester, I'll tell you right now.
But on a bright note, Monday's lecture
is one of the shortest. So you get a longer one today, but Monday will be a short lecture. Okay, so
since it's
is
called,
this thing on? Is this on? Oh, okay.
Since it's called rational and radical equations, why don't you tell them what a rational equation is? You don't need to write it out.
I'm going to write it out.
In algebra, rational means fraction. So we have okay, he's going to define rational.
No, I'm just going to say rational equations. I guess I will. I'm going to define it. It's an equation containing a fraction.
In algebra and in math, rational is just another word for fraction.
A rational number is defined to be any number that can be written as a fraction, one integer over another integer. A rational equation is an equation that contains fractions. We saw an equation with fractions at the end of class the last time. Well, but if I remember correctly, the denominators were just constants. There were numbers. There were no variables in them. Here, we're going to have variables in the denominators of the fractions. There's one thing, what we're going to do is we know we can multiply both sides of an equation by anything we want to, as long as it isn't zero. We can't multiply both sides by zero, but we can multiply by anything else in order to cancel out fractions. There's one problem though. We start off with an equation that contains fractions. We end up solving an equation that doesn't have fractions. There's one instance in which a fraction is undefined. So you could go through and remove the fractions and you get this great answer, but in the original problem, it wouldn't work. When is a fraction undefined? When is a fraction meaningless? That's what I mean by undefined. When is a fraction undefined? I'm just going to tell you right now because I have this way that you can remember it. A number divided by zero. If you have a number and your denominator is zero, then the fraction is undefined. Now think about why is that? Suppose we have, let's just say 8 over 2. Is that the one you were going to say?
Yeah,
8? That's what I was going to say also. Okay, I wonder how many times over the years I've used that same fraction. What's 8 divided by 2? 4. Now, what did you learn when you were learning arithmetic? What did you learn first? Division or multiplication? What comes first? Multiplication, because division is defined in terms of multiplication. We say 8 divided by 2 is equal to 4 because 4 times 2 is equal to 8. Now, if you have a number divided by 0, say you have 8 divided by 0. 8 divided by 0. What number times 0 is going to give you 8? There isn't one because no matter what happens, I'm going to write nothing. Good.
Because there's nothing you can multiply by 0 to get 8. Look at the calculator. What does the calculator do if I put 8 divided by 0?
It better gives, it gives an ERR, error. You're dividing by 0. That's not right. So we're going to have a general procedure for solving these rational equations. And I think I'll write out the general procedure, and then we'll start looking at the homework problems themselves, okay? Well, I guess I'll do problems 1 and 2 first. In problems 1 and 2, they're not asking you to solve the equation. They don't say solve the equation in problems 1 and 2. They're just asking you, if you were to solve the equation, what numbers would be unacceptable as solutions. So here's
You're not finding the solutions. In fact, you're finding the numbers that
are definitely not
Not
solutions. Let me write this problem down. 6 over 3x plus 1 minus 1 over x minus 5 is equal to 0. And notice it asks, what values of the variable cannot possibly be solutions for the given equation? They're not asking you to solve the equation, just what numbers can't be solutions. I see two different denominators. Neither of those denominators can be 0. So, this,
Let me see
switch
this.
over to my writing. Okay, I see two different denominators. Neither of them can be 0. So, 3x plus 1 cannot equal 0. Notice I put the little slash through the equal. We're going to work with it the same way you would if it were an equal sign. And the second denominator, x minus 5, cannot equal 0. Now let's isolate x. What am I going to do first here to get x by itself? Subtract the 1 to get that 3x cannot equal negative 1, and then divide by 3. So the first number that cannot possibly be a solution is negative 1/3. Come over here. Let's isolate x. What will I do? To give us x cannot equal 5. So we have found two numbers that can't possibly be solutions. Negative 1/3 can't be a solution, and positive 5 can't be a solution.
The instructions could have said, when are these two fractions undefined? Well, the first fraction is undefined at negative 1/3. The second fraction is undefined at positive 5. Okay?
So let's type these in.
Negative 1/3. Move right. Then put a comma.
I wonder if you left that comma in the denominator. It doesn't matter.
Okay, we don't have time to be playing
5.
with that. 5. Okay?
Okay, let's do another one of those. We're not solving yet. We're just asking ourselves, suppose I solve this problem number 1. Switch back to my writing.
Oh, you're writing?
Suppose I went through and solved this thing, and I round up with x equals 10. Would 10 be an okay solution?
Yeah.
Say yes, okay. What about, suppose I solved it and I wound up with 50 million. Would 50 million be an okay solution?
Yeah.
What are the only two numbers that we would have to discard as solutions? Negative 1/3 and positive 5. Okay, number 2, same type of problem. Once again, we want to decide the values that cannot be solutions. So we have 1 over x minus 2 plus 1 over x plus 1 equals 1 over x squared minus x minus 2. Make sure I wrote that down correctly. Let me see. Okay, go ahead.
By the way, there's two of these fractions are pretty easy to figure them out, right? Like this one here, which one do you think it's going to be? X can't equal 2. And what about this one? Negative 1. Now, this one I think isn't quite so easy. What do you think we're going to have to do with that in order to figure it out? Yeah, factor it. Okay.
So we don't want x minus 2 to be 0, which means x cannot equal 2. We don't want x plus 1 to be 0, so x cannot equal negative 1. And finally, this x squared minus x minus 2 equals 0.
Not equal to that.
Not equal to 0. Thank you. We say we're going to have to factor it. It's already, 0 is already by itself on one side. I'll write my two sets of parentheses. And how do you think this is going to factor? X squared. It's a simple trinomial. X times x. What do we know about the signs? There'll be a positive and a negative. And for 2, there's only one possibility. What times what equals 2? 1 times 2. So how about do y'all see what's about to happen? I think we need a minus 2 and a plus 1. Those look familiar. Where do they come from? Does that give us back the minus x that we need? The outer is a positive 1x. What's the inner?
Negative 2.
A negative 2x. The outer is a positive 1x. The inner is that negative 2x. Negative 2x plus 1x. Does that give us back the minus x that we need? Yes, it does. Where did x minus 2 and x plus 1 come from? That was the first two, wasn't it? Do we have any new numbers to exclude? No, we already have them. 2 and negative 1. And before we go on, I'm going to change the problem. Well, first of all, type in the answers. 2 and negative 1.
Knowing that you've done it correctly.
We've done it correctly, Tony.
Here you just type, it doesn't say x equal or anything, just 2 comma negative 1, is that it?
Right.
Okay.
Now, switch back here. I'm going to change the problem. I'm going to change this 1 here to an 11x. Don't write this down. I'm going to change this 1 here to a 7. And I'm going to change this 1 here to a 31x plus 15.
Does that change anything on this problem?
Does the value of a numerator matter when deciding whether a fraction is undefined? No, it does not. This problem here, even though it looks a lot worse because of the messier numerators, all you look at are the denominators when deciding whether an equation, whether a fraction is undefined. The value, it is a number divided by 0. No, that spells no. You can't do it. It's undefined. Any questions?
The no that's undefined, the on, 0 over an n, a number.
I do it like this. I say 0 divided by a non-zero constant k. That says okay. That's equal to 0. It's okay to have the 0 in the numerator, but if you have a 0 in the denominator, it's undefined. What about this one? Suppose it's 0 over 0. What did I say? If you have a 0 in the denominator, it is undefined.
Sometimes students think 0 over 0 is what? Okay, good, you don't know it. A lot of times people think it's 1, because anything over... No. A 0 in the bottom is undefined. It doesn't matter if it's 0 over 0. It's still undefined. And that's something that'll stay with us all semester long.
Yes, it will.
A fraction is undefined when the denominator is 0. But we've spoke for 15 minutes now without actually solving a single equation. So now it's time to start
trying to solve rational equations. I'm going to write out a sequence of steps. No, I don't give them that.
Oh.
I'm going to write it. I'm going to write a general procedure, okay?
Strategy.
I'm going to say, to solve rational equations. Just seems like we always have red pens. The office always has red pens. I think to myself, oh, I don't want to use red because someone may have trouble reading it, but invariably I just grab red because that's what we have the most of. the first thing, we're going to do what we did with that last problem in the previous assignment. We're going to multiply through by whatever it takes in order to cancel out the denominator, or all of the denominators. That's what we'll use will be the smallest denominator that'll cancel out every denominator. We'll call that the least common denominator. We're going to multiply both sides, and maybe you may have to make a note here. You're going to have to distribute probably by the least common denominator Do I see something flashing? I know. Is it this thing? Yeah.
I'd turn off that light.
I think so. Okay. Is that still bright enough? I guess it's bright enough for y'all. It's sort of dark for me, but that's okay. Multiply both sides by the least common denominator.
Cross cancel all of it.
You'll cross cancel. Cross cancel. And I'm going to put a note here. If you do this correctly, you should have no fractions remaining in your equation. If you do this correctly, I'll say note. If done correctly, you should have no fractions remaining. Then the second step, you have an equation that doesn't have any fractions. It'll either be linear or quadratic, because that's all we've solved so far this semester. So, the second one, here's where all the work is. Solve the equation. But there's a third step. Remember I said that fractions aren't always defined. We started off with something that had a fraction. We ended up solving something without a fraction. So you're going to have to go back and make sure that the number or numbers that you got as solutions don't give you a denominator of 0. All it is, it's as simple as looking, oh, suppose you got x equals 7. Would 7 be okay? If you had gotten an x equals 7, is 7 okay? What are the only numbers that wouldn't have been okay? Negative 1/3 and positive 5. So I'll say, I'm going to say, make sure your solutions don't give you a denominator of 0. How does that sound? Make sure your solutions, maybe I should say discard any solutions that give you a denominator of 0. But I've already gone too far. Make sure your solutions don't give you a denominator of 0. Now for finding the least common denominator, as we look through these, keep in mind what you're asking yourself. You're asking yourself, what can I multiply by in order to cancel out every denominator? Let's look at number 3 in the homework. That's number 3 right there, isn't it? Okay.
Like in this first fraction, there's no x in the bottom. You don't have to worry about it ever being 0. What about the second one? What would give us a 0 down here? Okay, is that screen blinking over there? Have y'all noticed that? Or is it just my vision?
It is.
I keep seeing that screen blinking, and I start looking and it doesn't do it.
I saw it blink.
Oh, okay. Well, okay, so what would make this denominator 0?
Oh, go ahead. I know what's wrong with that projector, so that's what I was whispering to him.
Oh, okay. So what's making this?
What will give us a denominator of 0 there? I heard it.
Positive 4.
Positive 4. So if we solve this thing and we get a positive 4, we're going to have to cross it out.
That's why we have this option right here. Every assignment, every problem starting with number 3 is going to have the option of an empty set. Because maybe you're going to get a solution that's not really a solution.
So,
go
before you write, I should have shown you, look at how I'm going to write this problem down. Switch over to, wait a minute, don't write it down if you haven't already. Wait a minute and let me write it down.
He's going to write it, spreading it out.
Now I'm spreading it out. I'm going to leave some room in front of each term. This first fraction is a term. Notice I'm leaving some room there. And what is the next one? Come back here. The 3x minus 2. Okay, switch back.
Notice how he spread it out.
Because I'm going to multiply through by the least common denominator to cancel these fractions here. I'm going to put something here. I'm going to put the same thing here. And I'm going to put the same thing over here. Okay. I look at the two denominators. Can I factor either of those denominators? This is a number, too. So there's nothing to factor there. Can x minus 4 be factored? When we were factoring, didn't we have what? X squares? X minus 4, that can't be factored. It's already a linear factor. So, if you have two distinct denominators, neither of which can be factored, your least common denominator is the product. You're going to have to multiply by 2 times x minus 4. Now, I'm going to make a note of that here. For my least common denominator, it's going to be the product 2 times x minus 4. Now, I'm not writing out a general formula for determining the least common denominator. I remember doing that once. Oh, that went terribly. So we're going to multiply here by 2 times x minus 4. And I'm going to show the denominator of 1 here just to make the point that 2 times x minus 4 can only be cross-canceled with what's down here in the denominator. I'll do the same thing here. Multiply by 2 times x minus 4. And here, is there going to be anything to cancel here on the right-hand side? Do you see a denominator there? So nothing's going to cancel. You're going to multiply by 2 times x minus 4.
Now this is going to look messy, okay?
Looking at the first product, what can I cross cancel? Something in the numerator with something in the denominator. This red 2 and that blue 2 down there. So we have x minus 4
Write down what's remaining.
Times 2x plus 3. Now the denominator, all we have is a 1, so we don't show it. We did what we needed to do. We got rid of the fraction. Minus. This minus right there, this minus, is this minus right here. What's going to cross cancel? Look at what we wrote with what we have down here. I don't think the 2's going to cancel. Just the x minus 4. The x minus 4 is going to cancel. Any questions on our logic there? And the 2 times 3x, I don't think we have to make that a separate step. I think you can tell me what's 2 times 3x. 6x, I agree. Any questions on our logic there?
The goal is to get an equation with no fractions. And I think we've already almost done it. Well, we have.
We have. There's no fractions here. I guess we have 2x times x minus 4. What are we going to do to multiply those?
Starts with a D.
Distribute.
Yeah.
2x times x. 2x times a minus 4. 2x times x is 2x squared. What's 2x times a minus 4? Okay. Well, we still have these parentheses here we're going to have to FOIL out.
Well, I was going to ask them what do we have to do there.
Yeah.
FOIL it out.
First, 2x squared, okay. Outer, 3x. Inner, negative 8x. Negative 4 times positive 3 gives me, and I still have that minus 6x right here equals 2x squared minus 8x. Let's combine like terms. We have a 2x on the left side. Let's just simplify the left side right now because that's what looks so bad. We have a 2x squared, 3x minus 8x. What's that? Negative 5x minus 6x gives us a negative 11x. We still have something on the left side. What is it? No, net 3x minus 8x. That's a negative 5x minus 6x gave us a negative 11x. What else have we got here? The minus 12, I agree. And we still have a 2x squared minus 8x. When we start thinking to ourselves, oh, this is quadratic. We better get it set equal to 0. Something nice is about to happen. This is the first one with variables, first fractional equation with variables that we've solved all the way, and they're being kind to us.
I don't think they're being kind. When you look at all of this, you know.
Really? I think they are.
But now at least, yeah, you're right. Now they make it a little bit easier.
Let's combine the x squared. We have a 2x squared here and a 2x squared here. Let's subtract 2x squared from both sides. What's about to happen?
Do we have any x squares remaining in this problem?
It turns out this is not quadratic after all. The x squares all subtract out. So we really just have a negative 11x minus 12 is equal to negative 8x. This is linear. We don't have to get everything set equal to 0 and factor. You have to isolate the variable terms on one side. I think the easiest way to get the x terms combined is to pick up this negative 11x and move it over here by doing what? Adding. If you move the 8x over, then you got to move the negative 12 to the other side. By doing it like this.
Yeah, fewer negatives also.
Yes. Anything that decreases the that correctly decreases the number of negatives is a good thing. So we have a negative 12 is equal to what's negative 8x plus 11x. 3x divide by 3 to give us x equals negative 12 divided by 3 is negative 4. Now, remember, what did we say x couldn't be? Oh, it's hard to see that denominator.
Oh, let me do this.
Yeah. What did we say x couldn't be? A positive 4.
4 minus 4 would give you 0. Negative 4 minus 4
is negative 8.
So
negative 4 is a perfectly acceptable solution.
Circle that in.
Circle that and type it in.
Okay. Negative 4.
Any questions there?
It's sort of messy. This problem has some messy manipulation. I mean, this assignment has some messy manipulations. Okay?
Number, what are we doing? 4?
But the semester doesn't just keep getting messier, the manipulation messier and messier.
No, it doesn't.
Okay.
And as I said, after this one, After this assignment, assignment number 7 is a very painless assignment and pretty short too.
Write it, spreading it out. Look at how he's doing it. See,
I left some room there.
Okay.
Oh, well, I should ask, just looking at that problem, what's the least common denominator going to be? What are we going to multiply by? Notice we have the same thing in both denominators. What would you multiply by in order to cancel out x minus 9? X minus 9. If you have the same thing for a denominator, then the least common denominator is necessarily x minus 9. I have another question. How many terms do we have there? Look back at what we had here in the previous problem.
Oh,
that's a bad problem.
Okay. Let's just go ahead and start. Get it written down.
Let me get it written down, then I'll go back to my... Well, before I do that, before I write it down, how many times am I going to have to multiply by x minus 9? How many distinct terms do I have? Remember, a fraction is a term, so we have 1 term on the left, 2 on the right. I agree, 3 terms. Good. Okay, I think that's fine. And so, what did y'all say the least common denominator would be?
X minus 9.
The only denominator you have is x minus 9, so that's necessarily the least common denominator. And you know something, right here where I'm writing that, what's the only x value that would be unacceptable? I'm going to write it down. X cannot equal what? Positive 9. You can't let x minus 9 be 0. So if we get something like 50, that's fine. If we get 17/3, that's fine. The only number we would have to cross out is 9. So we're going to multiply by
Can y'all do a little of this in
x
your
minus
head?
9 over 1.
Does this one look messier than the other one? Number 3, or is this one going to fall out a little bit nicer than number 3? Yeah,
I think it's going to be nice. So we're not going to pick up a bunch of foiling and x squares that we have to deal with. Let's cross cancel. What's going to cancel out here in the first product? The x minus 9s, leaving us what?
Blue.
Okay, that blue x equals, what's going to cancel here? The x minus 9s again, leaving us with the 9 plus, what's going to cancel here?
Nothing.
Because there's no fraction there. You still have to distribute the x minus 9, but there's no fraction. What's this going to give us here? 10x minus 90. I agree. So we have x equals 9 minus 90. 9 minus 90, that's a negative 81 plus 10x. Oh, what do y'all want to do? We have to, it's not quadratic, so once again we just combine our x's, isolate our x terms. You know, maybe we should do Tony's trick and minimize negatives. It would take a little more moving, but I can move this negative 81 to the left, and that becomes what? A positive 81, okay. So we are moving that over, that becomes a positive 81 equals, subtracting x, what are we going to have here? 10x minus 1x, I agree with 9x, and then divide by 9 to give us x equals 81 divided by 9 is, we multiplied 3 by the least common denominator, we solved the equation, the last step.
Am I going to type 9 in as an answer?
Make sure your solutions don't give you a denominator of 0. What did we say about 9? it cannot be 9. We cross that out. We didn't get another solution. So if it's not 9, then there is no solution.
Or I think it said the option it says is empty set.
The solution set is the empty set. Okay. So you could sit
I'm just
there.
curious, what would happen if I type 9 in? Is it going to say...
Is it going to say you got an extraneous... Oh, a number like this that looks like a solution but gives you a denominator of 0 is called an extraneous solution.
It just basically gave your strategy.
Yeah.
But it does say check the solution by... I don't like... You don't really need to plug it into the top or anything. You're just looking at the bottom. Plug the 9 in. Does it give us a 0 in the bottom? Yes. Okay, so I'm going to do that.
Number 5. So if we have distinct denominators that can't be factored, the least common denominator is the product. That's what you multiply through by. If you have only the same thing repeated as a denominator, then that's necessarily the least common denominator. Suppose you have repeated factors but different exponents. That's what's happening here on number 5. We have a 3x squared, a 3 over x squared. Remember to skip some space there. 53 over x is equal to 18. Okay, so moving up. Notice we have a monomial, a single term. We don't have a plus or a minus in the denominator. That's actually nice. We have repeated factors, x and x, but this one has an x squared. This one is just to assume x to the first power. If you have repeated factors in your denominator, the least common denominator is formed by using that factor. Well, you tell me. We're either going to multiply by x or by x squared. A common mistake is for people to multiply by x. That's a common mistake. If you just use an x here, are you going to cancel out that entire denominator? No. Your least common denominator with repeated factors, you use the same factor, but the largest exponent. So you multiply through by an x squared. When would those what's the only x value that would be unacceptable? What would you have to plug in there for x to get a denominator of 0? It should be obvious. Just look at this denominator here. What would I have to put there to get 53 over 0? It should be obvious. 0? If you put in x equals 0, wouldn't you have 53 over 0? That's the unacceptable answer. So we better not get 0. We're going to go through and solve, and we better not get a 0 as our final answer. We'll have to cross it out. Let's start cross-canceling. What's going to cancel here? Just the x squared? Well, not just. That's a biggie. The x squared. What are we left with? 3 over 1. That's just a 3. No fraction there. Be careful. We're going to cross-cancel. What are we going to be left with? What's going to cancel out, I should ask? Will that entire x squared cancel out? No, we only have one factor of x down here, so we're canceling out one of the x's. X and x. What are we going to be left with? 53 times x is 53x. On the right-hand side, what's going to cancel? Nothing, because there's no denominator. 18 times x squared is just 18x squared. Well, the first two, 3 and 4, we didn't have any. We didn't have to worry about getting it set equal to 0 and trying to factor it. But here, I think we're going to have to get it set equal to 0. It's quadratic. Now, the last time, remember I said I want the number in front of x squared to be what? Positive or negative? Positive. So with that in mind, I need to get a 0. Am I going to pick up this 18x squared and move it to the left?
Yeah.
No, because that would change 18 to negative 18. I'm going to pick up these other terms and move them to the right. So I'm going to have 0 equals, I have a positive 18x squared. That minus 53x, that's going to become a positive 53x and a negative 3. And we're going to, the instructions don't say use the quadratic formula, so I'm confident that this thing is factorable. Now, if I can't get it factored, I could always use the quadratic formula, but A equals 18, B equals 53, and C equals what? Negative 3. You'd want to have your calculator there because things like B squared, that 53 squared, would get pretty big. But as I'm looking at it, I got it. Do y'all see it? I remember trying to tell the people at that conference, your mental algebra really improves with this program because as a teacher, every time the problem's different. So, but 18x squared, there's 1x times 18x, or 2x times 9x, or 3x times 6x, 1x, and 18x. I think that's the one I'm going to try.
And what made you think that? Tell them your little trick about if the
Okay.
middle number's kind of large.
If the middle number is, well, first of all, I noticed that 18 times 3, I know that. I can do that in my head. That's 54. That's right close. That's only one off from it, isn't it? If this middle number is only one away from the product of those two, I try using, well, for 3, it's obviously going to be 1 and 3. There's no other choice. But for 18, the reason I chose 1 times 18 is because I knew 18 times 3 is 54. This number is only 1 away from that. So try 18x and 1x. I did ask y'all what we know about the signs. What are you going to tell me about the signs? Yeah, it's one of each. That last sign's a minus, so we're going to have one of each sign. Now, if I'm going to use for 3, I have to use 1 times 3. There's no other possibility, right? Could I put the 3 here with the 18x? If I put that 3 there, there's a common factor of what?
No, you can't put the 3.
3 there because there's a common factor of 3. So put the 3 here, the 1 there, and we're thinking to ourselves, that's a 1x. The inner, 3 times 18, that's a 54x. We know we need 1 positive and 1 negative to get a positive 53x. Where should the plus go? Where should the minus go? Which one of these do we want to be positive to get a 53x? The 54 we want positive, minus 1x, I agree. So to get a positive 54, where should the plus sign go? In front of the 3 or in front of the 1? In front of the 3 and the minus.
You'll follow that factoring.
Positive 54x minus 1x, that gives us a positive 53x. Is that what we needed? Yes, it was.
That check just means you factored it correctly. You're not finished.
Now we have to set each factor equal to 0. So we take x plus 3, set it equal to 0. Set 18x minus 1 equal to 0. This first one, moving the 3 over, we get x equals -3. Here, we move the 1 over, that gives me 18x equals, and then what do? Divide by 18 to give us x equals 1 over 18. What did I say? What's the only number that would have been unacceptable? And we didn't get 0, so both of these numbers are acceptable solutions. Any questions there? If you have repeated factors in denominators, but with different exponents, you use that repeated factor, but use the largest exponent. If you use the smaller exponent, if you just used an x, you would not have canceled out both x's in that first denominator. I know this is a lot to think about, a lot to absorb. Any questions there?
And also, it's sort of important every day. Okay, now how is this different from what we've been doing? Well, the last time we were solving quadratic equations, x squared, but they didn't have these messy fractions. So what are we doing different today? We've introduced, okay, the equations with the messy fractions.
And then we try to make them look like what we were doing yesterday. Although we didn't have any yesterday that were 18x squared plus 53x
We just got
minus
lucky
3.
with the numbers.
Yeah.
Okay, I mean, it could have been...
Oh, I went into the program. I hacked into the system and made sure they gave us real nice numbers.
I once had a student that was a programmer, and he was like, oh, he can get in there. He can change, yeah. I said, oh, please don't.
Please don't. And if you do, don't tell us.
Don't tell us, you know.
Okay, number 6. Okay,
I don't know
number
why
6.
that projector is flashing over there. It's annoying the heck out of me. But when class is over and everyone's left, I'll get a chair and see if I can, if there's a wire loose. Isn't that the most likely reason? Maybe there's a loose wire? I don't know.
That's it.
Oh, okay.
Okay. Can the first denominator be factored?
No.
No. Can the second denominator? No. So by our little least common denominator method, we would say it's the product is 4x. But I'm not going to do that. We have a fraction equals a fraction. That's called a proportion. Back in previous math classes, you would have solved proportions using this little method. It starts with the C. Does anyone remember what you would do when you had a...
2 words.
Starts with the C.
C,
Some sort of
second word is...
something multiply.
Oh, okay. So,
Cross multiply. Denominator times numerator. Denominator times numerator.
Product of the means equals the product of the extremes. A teacher would have said to you years ago, and you would have been like, what the heck does that mean? If you have fraction equals fraction, you can cross multiply.
And that's what I'm going to do. I'm going to take this numerator times that denominator. So we have a 2x minus 6 times 4 equals... I probably should have just distributed that already. I don't know why I'm making this problem longer than it is. We have x multiplied by x minus 2. I didn't need to show that. We should have done the distributing. 2x times 4 is an 8x minus, what do I have here? 24 is equal to, distributing, what have we got here? Minus, I agree. Oh, and I should have asked y'all before we went on, this denominator will never be 0. What's the only number you could plug in for x here that would give you a denominator of 0? It should be obvious.
0. Yeah.
So, as long as we don't get 0, everything's fine. Let's make a note. X cannot equal 0. Oh, it's quadratic. That means I'm going to need a 0 on one side. Do you think I'm going to get the 0 on the left side or on the right side? The left side, because I don't want to pick that x squared up and move it over, because that positive 1x squared, if I move it over, it's going to become negative. I don't want that. So I have x squared. Let's move that 8x over and combine it. We have a negative 2x plus 8x or minus 8x. Minus 8x, that's going to give us a minus 10x. What else do we have? Okay, pick that negative 24 up, move it over, that becomes a plus 24. Equals 0. It's a simple trinomial. Oh, it's got nice signs too. Let's try to factor x squared. That's x times x. And you're asking, how do you know it's factorable? Just from using this program for years and years and years, I've discovered if it's not factorable and it's quadratic, they're going to tell you use the quadratic formula. So, hey, we know something nice about the signs. The last sign's a plus, so, okay, good. And 24. You have 1 times 24. It could be 1 times 24, or 2 times 12, or 3 times 8, or 4 times 6, 5. Is that all of them? 5 doesn't go in evenly. Is there another pair? No. So it's a simple trinomial. Choose the pair. Okay, 4 and 6. 4 plus 6 give you that 10 that you need. And set each factor equal to 0 to give us x equals or good. You ate those Wheaties this morning, and you're really on the ball today.
I got from math major for husband.
Oh, you joke! Oh, so you good for you? Okay. Okay.
4 and 6.
Oh, and by the way, remember the only number we said that wouldn't be acceptable is 0. We didn't get 0, so these numbers are fine. There and there.
4, comma 6.
Okay. Number 7 we'll come back to if we have time, okay? But I know...
Well, I said get to it.
Okay. You're right.
How long have we been going?
303. Okay, good. Okay. This is the last... I think this is the last equation with fractions. Okay. Let me write it down. And while you're looking at it, you can tell me what's the least common denominator and how many times are we going to have to multiply by that least common denominator? Okay.
X minus 2 is the least common denominator. It's the only denominator.
It's the only denominator, so it has to be the least common denominator.
So you're going to multiply the fraction, the number 5, and the fraction. Even that number 5 gets multiplied by x minus 2. So
why am I not cross-multiplying here? Why am I not cross-multiplying? You only cross-multiply when a fraction equals fraction. What's wrong? If I could erase this one thing, then we could cross-multiply.
Oh, but that would make
it so much worse. I know, you're right. So you're right.
If you didn't have that 5, you could cross-multiply.
So we're going to multiply by x minus 2, x minus 2, x minus 2.
Cancel.
Okay, so we cancel the x minus 2's. What's that going to leave us? 2x equals here.
5x minus 10.
Okay, there's nothing to cancel. There's no fraction. You're just distributing 5x minus 10. Good. Here, what's going to cancel? The x minus 2's cancel, leaving us that plus 13x squared. And it's quadratic. We're going to have to get a 0 on one side. What do y'all think? Am I going to move this stuff on the right to the left? Move the 2x over there. Get the 0 here on the left side. So we have 0 equals. And the reason we're doing that is because we want that number in front of x squared to stay positive. So you have a positive 13x squared. Subtract your 2x. What's that going to give me here? 5x minus 2x gives me, okay, and I still have, okay, and the numbers haven't been that bad so far. Now, there'll probably be some with, 365 popping up as as a C value, something like that. If that happens, I'm just going to go to the quadratic formula. But so far, they haven't been bad. 13x squared, there's only one pair of integers you can multiply, positive integers you can multiply together to give you 13. 1 times 13, so I'll just write 1x times 13x. For 10, there's two possibilities. 1 times 10 or 2 times 5. What do we know about the signs? Last sign's a minus. So 1 positive and 1 negative, 1 plus, 1 minus, however you want to say it. I'll make that note there. It's going to be a plus and a minus. I see it. Do y'all?
Yeah. There's something I'm noticing. Like 13 and 10, if we subtract those.
What do they give me? What does that give me? 3? That's another one of those instances. If the numbers subtract, the A and C subtract to give you that number there, try using, well, for 13 you don't have a choice. You have to use 1 and 13. But for 10, try 1 and 10. I'm not going to put the 10 here. If I put the 10 here, 10 times 13, that's 130, way off from what we need. So try the 1 there and the 10 there.
Again, like that student said, you're just making it work out. Now, how do we arrange the, are we going to get?
Are we going to have an x plus 1 or an x minus 1? Remember, we want to get back a plus 3x. A plus 1, let's check. Let's check this one here.
If you started foiling, you'd have 13x squared. You don't need to show that.
Then you have an x times a negative 10. That's a negative 10x. 1 times 13x. That's a positive 13x. I'm not going to show the little bars. It uses up too much space. And we're running out of paper. So, is that going to give us back the plus 3x that we needed? Yes. So we set each factor equal to 0. X plus 1 equals 0. 13x minus 1. Minus 10 equals 0. That's going to give us here x equals negative 1. I agree. This one here, what would I do first to solve this? Add 10 to give me 13x equals a positive 10, and then divide by 13 to give me my next answer of 10 over 13. Oh, I should have asked y'all. Look back at the original problem where it's written neatly. What's the only x value we'd have to discard? What would give us an undefined result? Looking at the original problem, look at that first denominator. What number, when plugged in for x, would give us a denominator of 0? I couldn't hear you. Positive 2. Did we get a positive 2? Look at our work. No. These answers are both acceptable. So negative 1 and positive 10/13.
Negative 1, comma, 10/13. I'll check it. Okay.
And now we're ready for the second half of the assignment. Radical equation.
Rational, that means fractions, and radical. What does the word radical?
Radical doesn't mean bizarre or anything like that. That's not the type of radical we're talking about. Radicals are square roots, cube roots. Those symbols are called radicals. So radical equations.
You know what, Tim? I want to review something on day 1.
Okay, I'll let you do that, okay?
I love having everything ready right here.
Well,
we might have stated it better over here. Okay. We stated a rule. Oh gosh. On the first day, about a square root times itself. And let me see. I'm looking through my notes. Boy, I remember back in the olden days when stuff was written on the board, and once I erased it, it was gone, and I couldn't refer back. I love this. We said a square root times itself is just whatever's under the square root, and another way to write a square root times itself is a square root squared. And from that we said, okay, so a square and a square root cancel each other out. That's going to be very significant. You can watch back the video. On that day I said, we'll use this rule all semester. Well, here we are, ending up the 3rd week already, still using that rule. So let me make a note of this, of that rule. We said that if you take a square root and square it, the square root and the square cancel each other out. And leave you just whatever's under that radical sign. Notice, when we have this little symbol here, we read it as square root. The number, if you're writing a cube root, and we haven't done anything with cube roots today, until today. So we have the cube root, that little 3 there is called the index or the root. The cube root, there's a rule similar to this. Square and a square root cancels it out. What do y'all think I'm going to say about a cube root? What exponent right here would cancel out a cube root? Another cube? So cube and a cube root cancels out. And we could go on and on. If we had a 4th root, I'll write it right here. A 4th root is one of those little funny symbols, but with a 4 right here. See, there's always a number right there, but if it's a square root, you don't have to write the 2. But it's still, we say square root, so there's a 2 there. So raising a 4th root to a 4th power, that cancels out. In general, here's a rule we'll see if it's just some nth root. So it doesn't matter if it's a 7th root or a 10th root. If the little root and the exponent are the same number, they cancel out. Now, having said that, let me go ahead and show you what the next problem looks like.
But don't bother writing it down yet.
See, here's what we mean by radical equations. This one has a square root. And like number 9, another square root. Eventually, another square root. Oh, a cube root. So hit number 11, you're going to get the cube roots. Don't panic. The cube roots are easier than the square roots. So let me put it on there. You're going to write out a strategy for solving equations with radicals.
Okay. To solve radical equations. You know, before I write out that strategy, I want to point out something. The way he was talking about the raising the radical to power, and it would cancel out the radical symbol. So if we had something like
EX, for example.
EX for an example, and EX means an example I'm making up off the top of my head. Let's suppose we had something like the square root of x plus 4 all squared. If you square the square root of x plus 4, as long as everything's under the radical, that square cancels out the square root, and it leaves you the thing under the radical. The thing under the radical is called a radicand. So it would just be an x plus 4. Suppose the plus 4 had not been under the radical. Look at this one. Suppose we had the square root of x, and the radical's closed off now. The plus 4 is on the outside. Suppose we squared both sides.
Squared.
No, I mean, suppose we'd squared the expression, not both sides. We don't have an equation at this point. We're just simplifying this algebraic expression. What would we have to do? We have a sum that's being squared. If everything's under the radical, then great. The square undoes the radical, leaving you the radicand. But here, that plus 4 is not under the radical. And don't say square this and get an x and square that and get a 16. I remember squaring a sum or else a difference when we were looking at complex numbers. Something like 2 plus 3i squared. What do we have to do there?
How do we square this? If it had just been x plus 4 squared, you wouldn't just square the x and square the 4.
What would you do there?
It starts with the f.
A sum or difference, you got to write it twice and FOIL it out. So to simplify this, that square root of x, you'd have to write it twice and FOIL it out.
That might happen in these problems.
And, well, let's start FOILing it out. The square root of x times the square root of x. That's like the square root of x squared. What's that going to give me? First, x, okay. The square root of x times 4, that gives me a plus 4 times the square root of x. Nothing we can do to simplify that, just square root of x times 4 is 4 times the square root of x. You tell me what the inner product is. 4 times the square root of x is another 4 times the square root of x. And last times last is 16. We started off with something containing a square root and we squared it. Did we eliminate the square root? 4 square roots of x plus 4 square roots of x, are those canceling out? No, and if we combine the 4 plus 4, we then have 8 square roots of x. So it's possible you could square a square root and you don't get rid of the square root. As a matter of fact, you get something that's messier, don't you? If you're going to eliminate a radical, you can't have something added to or subtracted from it. That's the whole point of this. You're going to want to isolate a radical. Before you start squaring both sides or cubing both sides, you're going to have to isolate a radical term. Don't have the square root plus something or the square root minus something. If you do, you move that something to the other side of the equation. Look at that number, which one was it? I think it was number 9. I think number 8 does it. It's that square root is not isolated. You don't want something added to or subtracted from that square root. So what I'm going to say to solve radical equations, so that you don't have something like what just happened here. You squared a square root term and you got something that looks even worse. To solve radical equations, the first thing you need to do, you need to look at, you decide, okay, I want to isolate a radical. I don't want to start raising both sides to a power until I've got a radical by itself. I just say a radical because there may be more than one square root in the problem. But first step, isolate a radical. And then whatever type of radical it is, raise both sides using that using the index of the radical. So for a square root, you'd square both sides. A cube root, you'd cube both sides. A fourth root, you'd raise both sides to the fourth power. So I'm going to say, raise both sides to the power of the index. Do y'all understand what I mean there?
If it's square root, square. If it's cube root, cube.
And then step number 3. At this point, if you do that correctly, you'll have something without a radical, so you'll solve the equation. And there's a fourth step.
If I say even numbers, y'all know what I mean by that? 2, 4, 6, 8, 10.
If your radical has an even index, that's a square root or a fourth root or a sixth root. If you're working with an even index radical, you are going to have to check your answers, because raising both sides of an equation to an even power doesn't guarantee equivalence. So we'll discuss that in a moment. But I'm going to say, check your solutions. And you can do the checking with a calculator pretty quickly. Check your solutions for, I'll say, square roots or fourth roots or sixth roots.
In general, any even root.
If it's an even root, you're going to have to check your answer. Now, a moment ago, Tony flashed up there a cube root on the screen. And Tony said cube roots are easier than square roots. If you're working with a cube root, what power are you going to put on both sides? 3? Is 3 an even number? No, so you get to skip this last step. That's one of the reasons I like cube roots. Let's discuss just for a moment before we start working an example. Why? Why do we have to check our answers? I claim that even exponents cause all sorts of problems, because an even exponent, it'll take something that's negative, and when you raise it to an even power, what result do you get? If you have something negative and you raise it, say you square it, what sign do you get? You have a negative to an even power. Isn't that going to give you a positive number? When you're going through raising both sides of an equation to an even power, you run the risk of taking something that's negative and accidentally changing it to positive. For example, I think you'll agree as long as I have this statement here, look at what I've written. Isn't that a true statement? Negative 3, when it's squared, it equals the same thing as positive 3 squared. As long as you have those even exponents there, that's a true statement. 9 equals 9, right? Suppose we drop the even exponents. Is this still a true statement? No, it isn't. That's the problem. When you're raising both sides to an even power, you run the risk of taking something that was negative and accidentally changing it so that it's positive. So that's why we'll have to check our answer.
Let's go ahead and do number 8.
Let's do number 8. Okay, let me write it down. And as we run into these quadratic equations, if I can see the factorization quickly, then great. I'll get it factored. Otherwise, if I can't get it factored quickly, then I'm going to convert over to the quadratic formula and identify my A, B, and C values. There it goes. Okay, switch over. The first step, we must isolate a radical. There's only one radical. That's the thing we have to get by itself. I think to get this square root by itself, the easiest thing to do is to pick up that negative square root, pick up this negative square root and move it over to the right. When we do that, what happens to that negative? It becomes a positive, okay? So we just have x equals the square root of 16 minus 6x. We isolated a radical. The next step, I don't see an index there, but what sort of radical is this? Square root, so we're going to square both sides. Put squares on both sides. So on the left side, we have x squared equals, notice everything there's under that square root. So when you square the square root, what are you going to get? Okay, that square cancels or eliminates that square root, so we just have a 16 minus 6x. It's quadratic, that means we have to get it set equal to 0. I agree. We don't want to move this one to the right because then that positive 1x squared will become a negative 1x squared. So keep that where it is. Let's move these two terms over to give me x squared. That'll become a plus 6x, and what else? Minus 16 equals 0. Well, this one isn't bad. It's a simple trinomial. I keep talking about them. You know, sometimes they're really bad. I mean, the things that we wind up with, it's hard to get factored, but we haven't run into one of those yet. Maybe we won't today. What do y'all think about the signs? What do we know about the signs? One's going to be positive, one's going to be negative. The last sign's a minus, so you have you have 1 plus and 1 minus. Now for 16, 1 times 16, 2 times 8, or 4 times 4.
2 times 8, is that what I heard?
I agree with 2 times 8.
And you chose that because if we subtract those numbers, we get 6.
Okay, now play it out in your head. To get a positive 6x from the outer and the inner, what should we have here? A plus 2 or a minus 2? A negative 2 and a positive 2? Let's check.
A positive 8.
A positive 8? Let's check. What's the outer product?
8x.
X times 8, that's a positive 8x. What's the inner product? Positive 8x minus 2x. Does that give us a positive 6x? Yes? That's what we needed. So that's the correct factorization. And now, set x minus 2 equal to 0 and x plus 8 equal to 0. Solving this first equation for x, we get x equals this one here. And we're going to have to physically, this isn't like the thing when we're checking, does it give us a denominator of 0? We're going to have to physically plug in 2 and make sure the left side equals the right side. We're going to have to physically plug in that negative 8 and make sure the left side equals the right side. Here's my advice to you. When you're checking, use the isolated form. I'm not going to go back to the original problem. Use the one where the radical was isolated. What was it? We had x equals the square root of 16 minus 6x.
Don't use it with the squares.
Well, if you use it with the squares, it's definitely going to be true because you already got the square there. But use it where the radical is isolated. So we have x equals the square root of 16 minus 6x. Let's plug in 2 here.
Yeah.
So we have 2 equals the square root of 16 minus, what's 6 times 2? 12. Does the left side equal the right side? 16 minus 12 is 4. The square root of 4 is 2. Does the left side equal the right side? Yes. So 2 is an acceptable solution.
You will certainly not be choosing the no solution answer, part B. Okay? So your answer is going to be part A. You either type in 2 and negative 8 or just 2. Let's check with negative 8.
So we're plugging it in right here in the original. X equals the square root of 16 minus 6x. I plug in the negative 8 for x equals the square root. I can stop at this point. I'm not doing anything else. I know this isn't going to work. Here's why I told you to use the isolated form. I don't see a sign in front of this radical. If you don't see a positive or a negative, what sign do you assume it's going to be? Positive? Can a negative 8 equal a positive number? No. So you don't have to go through and check the rest. If you use the isolated form, it's easier to spot the numbers that are not solutions. Y'all understand my logic there? Those of you in the peanut gallery, y'all understand my logic? Use the isolated form.
And I have to say, I always used the original form until I started teaching these classes with Tim. And the day Tim said, oh no, use the isolated form, it's so much easier. I'm like, oh my gosh. I've been doing it at that point for 30 years. And he was right. Okay.
So the negative 8 doesn't check, positive 2 does check.
So let's see. Positive.
I wonder if you put 2 common negative 8, what would they tell you?
Let's see. We don't really have time to be goofing off like this, but we'll try. No.
One or more of your responses is incorrect.
And they just isolate, square both
They
sides.
say check in the original. I say check in the isolated equation. The one that still has the radical. Any questions? Number 9.
And number 9 is the...
Traditionally, at this point in this class, I can always say number 9's the messiest one. Number 9 is the messiest one, so...
Once you've made it through number 9 and done your number 9 in this homework assignment, give yourself a pat on the back, as you've done some really messy algebra manipulations.
Let me make sure. Okay. what exponent are we going to use on both sides? Square, cube, fourth, which one? Because it's a square root. Do I start squaring both sides now, or do I have to move stuff around? Move, what do you think I'm going to move? I'll tell you right now, this square root is the thing I need by itself. So move the 3 over by adding 3, I agree. So we have the square root of 7x minus 20. That's a 2x. Negative 13 plus 3 gives me a. And we have the radical isolated, so we can square both sides now. Square, square.
Why have I said this is going to be messy?
Well, the left side's working out great. What's the left side going to reduce to? 7x minus 20, I agree. The square undoes that square root, so we just have a 7x minus 20. What about on the right side? What are we going to have to do to square 2x minus 10? I'll tell you right now, you don't just square the 2x and square the 10. FOIL it out. You have to write it twice. That's what I'm doing right here. We have to write it twice and start foiling out. Okay, first, 2x times 2x is?
4x squared.
Okay. I know.
I'm afraid
Okay.
it's hitting them in the face at this point.
2x times a negative 10 gives me negative 20x. I saw someone mouthing it here. Another negative 20x.
I saw someone thinking it this time.
Negative 10 times negative 10 gives me a positive 100. Good. I'm not liking the size of these numbers, but there's nothing I can do about that. I'm stuck with these numbers that they gave me, just like you're stuck with the ones that you were given, okay? I see that we have an x squared. We're going to have to get this thing set equal to 0. And,
Why not combine these 20x's?
okay, that's a negative 40x. Okay, I'll do that. I'll make a separate step there. I was going to combine everything all at once. Negative 20x minus 20x is a negative 40x. We're going to have to get it set equal to 0 because it's quadratic. Do you think, what are we going to do? Are we going to get the 0 on the left or on the right? I guess the better question is, what do you think I'm going to do? I'm going to move everything to the right because I want that 4x squared to stay a positive 4x squared. The number in front of x squared should always, whether you're trying to factor it or use the quadratic formula, you need to make sure that a value is positive. So I'm going to have a 0 equals, I have a 4x squared. So, there. We have a negative 40x minus 7x. What's that going to give me? Negative 47x plus. Okay. I see one thing I like about this. I like the fact that that last sign is a plus.
Should we do a quadratic formula here just to show how to do it with a calculator?
I think I'm going to do it both
numbers?
ways. How are we doing on time?
Oh,
I think I can do it. I think I can do it. If I
do-
can't get it done quickly, then okay.
Well, I can factor it quickly, but I thought, okay. If you started like for 4, what are the numbers? 1 times 4.
You can't
and
use a 2 times 2 because 120 Well, you may have a 3 times 40 or a 2 times 60, but at least one of the numbers for 120 will always be even. So you can't use 2x and 2x. That's my real fast thinking. Is that how you're thinking? And so, don't bother writing this down, okay? I'm just going to see if I can get it done.
Well, why not?
Well, you're right. Write it down. 1x and 4x.
What sort of signs?
So it's not 6 and 20. Oh, what do we know about the signs? I didn't write it down. They're both going to be negative. I got it. There's 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24. I think that's it. You see, we can't use a 260 or a 4 times a 30 because you'd wind up putting an even number with the 4x.
What, 5 times 24?
I think that's doing it. No, it isn't.
No, I don't think so.
You're right. I was thinking it was 5 times 24. We may be using the quadratic formula after all. Okay. Okay, that can't be it. 24. Yes, it is. No, it isn't. You're right.
5. 24 times 4 is?
24 times 4, that would be 96. So that's not it.
I know. So, let's see. 1 times...
Wait a minute. I said I'd only do it for a few... I said I'd only spend a few minutes on this, Tony. And I think I've spent a few minutes, right?
Mm-hmm.
So go to the quadratic formula.
All right.
Let's identify A.
4.
4. Okay. Y'all tell me what B is. Negative 47. C. 120. And I'm right in saying we didn't see one like this yesterday with such large numbers in the quadratic formula. I'm confident this thing is factorable, but I just don't see the factorization.
The quadratic formula, I'm going to keep thinking
Let's
about
identify. O. Negative b plus minus the square root of b squared minus 4ac all over 2a. Do you have our calculator opened up, Tony?
Mm-hmm.
Okay, negative b. What's that going to give us? The opposite of negative 47 is a positive 47. And then b squared. Yesterday I'd say, oh, do that in your head. Today I'm going to write that out. Negative 47 squared minus 4 times A times C A is 4, C is 120, all over 2 times A. We can do that in our head. What will we have for our denominator? 8, I agree. Now, think about when we're solving by factoring. When we're solving equations by factoring, do we pick up square roots in our answer? If you're solving by factoring, you get rational numbers. We didn't have square root symbols popping up when we solve an equation by factoring, like here. This number 7. There's no square roots popping up in our final answer. If this equation really is factorable, that means this thing under the radical has to be a perfect square.
So I've squared the 47. Now let me continue. Minus 4 times 4 times 120. 289.
That's a square. That's a perfect square. Is it the square root of 289 17?
Well, they may not realize that. Let me go ahead and say the square root of 289 is 17. So the fact that this will factor means you don't have a square root in your answer.
If you have a square root in your final answer after using the quadratic formula, that means the equation is not factorable. The fact that we have a perfect square there, yeah, this is going to be factorable. So
Replace.
we have 47 plus or minus. The square root of 289 is a 17 all over 8. And don't stop there. Now, the last time, whenever we used the quadratic formula, we had a radical remaining in our answer, right? Here, we can reduce until we get two rational numbers, maybe integers or fractions, but we're not going to have a plus minus as part of our answer. Let's see, we have 47. Let's break it into pieces. 47 plus 17 all over 8. The other possibility is 47 minus 17 over 8. Let's do the 47 plus 17 over 8. 47 plus 17, is that a 64? Divided by 8.
So it
Is
should have
8.
been 8 and 15.
It should have been 8 and 15.
How many of y'all had already figured out we could have factored it with 8 and 15? That was the pair of numbers that neither of us thought of. Well, anyway.
47 minus 17, that's 30 over 8. We can cancel a 2 above and below to give us 15 over 4. So it could have factored as x minus 8 and 4x minus 15.
All of that, and I don't think you're finished yet.
We're not finished yet. What do we have to do? Since it was raised to an even power, what are we going to have to do? Oh, we're going to have to check our answer. And so I'm going to come over here.
Write the equation once it's been isolated.
Yeah, okay, we have x equals 8 and x equals, what was it, 15 over 4? And remember, my advice to you is to to check it in the isolated equation. So you have the square root of 7x minus 20 is equal to 2x minus 10. Look back at the original, here it is. The original problem, we moved that minus 3 over by adding 3. So we had the square root of 7x minus 20 on the left, and a 2x, negative 13 plus 3 gave us a minus 10 on the right. Plug in 8. 7 times 8 is 56, minus 20. That's what? 56 minus 20 is the square root of 36, which is 6. Plug in the 8 there. 2 times 8 is 16 minus 10 is 6. Does 6 equal 6? Yes. Okay. Let's plug in the 15 fourths. Let's see. Now remember, let's pull that trick we tried earlier. What sign is the left side going to be?
Positive or negative? When you have a square root, it's...
I don't see a sign there, so you know the result's going to be positive. 2 times 15 fourths minus 10.
Write it out while I punch it into the calculator. Oh, where'd my calculator
I think that's
go?
negative. That's going to be 15 halves. So 7.5 minus 10, I think the right side's going to be negative.
If I go 2, parentheses, 15 over 4, close parentheses, minus 10. Is that giving me a negative number?
Then it's not working. and then 15/4 cannot possibly work, because when you plug it in here, the result has to be positive. There's no negative sign in front. A positive cannot equal a negative. So discard 15/4. Any questions on our logic? It's just hitting y'all in the face, isn't it? It's just hitting you in the face and bouncing back everything we're saying. It's not sticking in your brain right now. Well, we're getting close to the end. We only have about 4 more problems to do. And this is the worst one. This is the worst one.
The worst one by assignment? Or what do you
By
mean
this assignment. This is the worst problem in the assignment. Number 9, it's always different, but
Now,
but it's
everyone's number 9 is always the mess.
the messiest.
But number 10, does it look worse? No.
Switch back to my paper.
Oh.
Let me see if I...
Can you get it all on one shot?
Well, if
Oh,
I
you
can, I
can.
could, yeah.
Because you can't get
There's a-
checking on the same.
No, of course not. I'm just asking. We isolated. Then we squared both sides. Over here we had to FOIL, okay? We got it set equal to 0. We tried to factor it, but I didn't see the factorization, and neither did Tony. So after a few minutes, we went on to the quadratic formula. Now, if it's factorable, and I'll tell you another reason, it's going to have to be factorable, because if it weren't factorable, you'd have to try to plug it in and check, and that would just
And
get
if I can
really
interrupt
messy.
whoever's phone that was that just rang, if it happens again, I'm going to drop you. And I'm joking. If you're watching this video, it was my phone. I'm joking about that, okay?
Okay.
Well, anyway, let's go on to the next one, Tim.
Okay, any questions?
They wouldn't know where to start.
Okay, then let's go on to number 10.
Let's,
Oh, why did you let me do that?
I know, paper's free, I guess.
Oh, no, it isn't. Let's write this one down. I can already tell this problem looks better than number 9. Do you agree? I can already tell this looks better than number 9. There are fewer terms. The thing under the radical is easier. Are we going to have to move terms around? You tell me that. Yes. What power are we going to raise both sides to? 2, because it's the square root, and we want that square root right there by itself. So, moving the x plus 8 over to the right.
Negative x.
I mean the negative x plus 8 over to the right. We're going to have what here?
Positive x.
Positive x minus 8. And you know what? I'm going to recopy that, because this is what I'll use for checking. I'm going to keep that like that, and this is what I'll use to check. It's that isolated form that I think makes it easier for checking.
And you're right.
So,
You're right.
you know, Tony, you remind me of Johnny Carson and Ed McMahon.
Yeah,
Whatever
no
Johnny
one in
Carson.
here
No,
knows
but
who
you
that
do.
is, yeah.
I mean, but you remember Johnny Carson would make the lamest jokes on late night, and Ed McMahon would sit there on the sofa just laughing. And so, whatever I say, Tony backs it up and agrees with me. Oh, this is the best way to do it. Oh, I agree.
Shut
Okay.
up, just go.
What are we getting here? I'm getting tired of talking, so I'm going to let them tell me. That's going to reduce just to 4x. What are we going to have to do here?
Starts with F.
Not factor,
The
the other F.
word. Yeah.
4 letters,
Foil.
write it twice and FOIL. Keep in mind, Monday's assignment's going to be a lot better. Okay? First, well, it's going to be a lot shorter and easier. I should
Spoil it out, Tim. They can do it.
First is x squared. X times negative 8 is a negative 8x. I'm trying to knock them out of their stupor. Okay, because it's all,
The more you talk,
their
the more
eyes are
they'll
glazing
see it.
over. Inner, what are we getting here for our inner product?
Another minus 8x.
Okay. Now, Tony, you be quiet. Let them tell me. Last times last.
Negative. Yeah.
Positive 64. Okay. And I need what number? This equation needs to be set equal to? Will I get the 0 on the left side or on the right side? The left side. I want that x squared to stay a positive 1x squared. So I have 0 equals x squared. Negative 8x minus 8x is negative 16x. And then what do we do?
Negative 8x plus 8x, they would have
and we wouldn't have been that lucky. I mean, have you noticed that
this
would
has not been a lucky day with numbers here.
Okay, so that's a negative 16, and what do we do with the 4x? Subtract negative 16 minus 4 gives us a negative 20x, and we still have 64. Oh, it's a simple trinomial. So we should be able to get this one factored without too much trouble. X squared, x and x. We know something definite about the signs. We don't have to have one of each. What are we going to have? Last sign's a plus, so 2 of the first signs. And that's another thing. That rule that we use for the signs, it only works if the number in front of x squared is positive. That's why whether you're factoring or the quadratic formula, you need your a value to be positive. Now 64, 8 times 8 is the first thing that pops up in my head, but that certainly wouldn't give us the 20. So we have 1 times 64, 2 times 32, 3, 4 times 16, 5, 6, 8 times 8. Which one are we going to use? It's a simple trinomial, so you can choose the pair 4 plus 16. That gives you the 20. Play it out in your head. The outer is negative 16x. What's the inner product? Negative 16 minus 4. Sure enough, that gives us the negative 20x. So what do we do next? Set x minus 4 to 0. And x minus 16 to 0 to give us x equals 4. And here, x equals, and
check.
We're plugging it into the isolated form. The square root of 4x. I'm going to do, okay, hold on. Move that. Yeah, there. Okay, so we're plugging it into the square root of 4x is equal to x minus 8. I can tell that 4 isn't going to work. 4 minus 8 is negative 4. What sign do we have there? A positive. Can negative 4 equal a positive number? So 4 does not work. If you had to guess, what would you think is going to happen here on the next one? You think 4 didn't work. You think 16 is going to work? Let's check and see. Okay, the square root of 4x equals x minus 16.
No, x minus 8.
X minus 8, pardon. So 16, 4 times 16, that's the square root of 64, equals 16 minus 8. Is that a true statement? What's the square root of 64? 8. What's 16 minus 8? I think 16 checks. I'll tell you right now, for these square root equations,
Something checks.
it is very difficult to rig a problem of a square root equation where there are two extraneous solutions. By that I mean two numbers that you get, neither of which check.
It's possible.
It
but
is
it's
possible,
very rare.
but it is very rare. So if you were running out of time, okay, this were a test and you were running out of time and you knew 4 wasn't going to work, what should you think is going to happen with 16? What do you think probably is going to happen? It's going to check, okay?
So,
16 checks, 4 doesn't.
okay, plug it in. Oh, let me do that. 16 checks. Okay,
Any questions there?
let's get to number 12. Oh, wait, or number 11.
I thought number 12. Oh, we'll do them both.
Okay.
Okay.
If you have to go, if you just can't stand it anymore, the video will be out. Okay?
It'll probably take 4 days to upload.
Yeah.
It's going to be so long, but that's okay. Number 11. Okay. We have a cube root of
Are we gonna have to
5x plus
check
7
this?
plus 9 equals 1. What power are we going to raise both sides to? 3. That is an odd number. Remember, for checking, a few days ago when I wrote those steps up, where are they? Here it is. You only have to check your solutions for even indices, square roots, fourth roots, sixth roots. This is a cube root, so you don't have to check the answers.
There's only one first step that's correct.
What is it? What am I going to do? Subtract 9. You've got to isolate the radical. So we're going to subtract 9.
If you do anything other than subtracting 9 first, whatever it is, you're messing up.
1 minus 9 gives us a negative 8. And then we're going to, we're ready, we have the radical isolated, so we will raise both sides to what power? 3. Okay, so we're cubing both sides.
We're ending on a lighter note.
The last problems are easier. What's the left side going to reduce to? 5x plus 7. Now, what's negative 8 times negative 8 times negative 8? Don't say negative 24.
Negative 512.
You see, when you raise both sides of a negative number to an odd power, the sign doesn't change. Cube roots get a bad rap. People, they don't like cube roots. They like square roots. Square roots are the things that cause the problem. Square roots are the things that make those imaginary numbers. Cube roots, cubing stuff doesn't change signs. If you have a negative quantity and you cube it, it stays negative.
And you've talked enough about that.
Are we going to have to square, do we need to get this set equal to 0 and factor?
How do we know we don't?
What do you not see here? X squared. This is linear. We just got to isolate x. So let's get rid of that 7 by doing what? Subtracting 7. So that says 5x is equal to negative 519. And then divide by 5 to give us x equals negative 519 divided by 5. Do we have to check?
No.
No, because it was an odd number.
Odd root. Or
Odd, so don't check. You can check if you want to, but it's got to work.
Negative 500.
No, click in the box.
Oh, shoot. Negative 519, I forgot. Over what?
5.
5. Okay. Now let's do 12, which looks terrible, but after everything else you've been through today,
It's
This'll
not
be-
really that bad. Okay. The cube root of 6x squared plus 5x minus 5. I like the way the problems are different. From a teacher's point of view. True, I can't just
memorize the problem.
memorize the problem and go through and do the same problem over and over with every class, but I like
I
that.
prefer different numbers.
There's really only one sensible first step.
Stuff.
Remember I'd said the first step, isolate a radical. Well, there may be more than one radical. You've got to isolate one of them, though. If you do what I'm thinking, when you isolate one, you're going to isolate the other as well. Which radical do you think we should move? If we pick up that second one and move it to the right, what's going to happen to that minus sign there? So we're going to have one cube root equaling another cube root. Am I going to have to check my answers at the end? No, because I'm cubing both sides. And then it reduces pretty nicely.
Yeah.
The cube undoes the radical, giving us just a 6x squared plus 5x minus 5. What have we got on the right-hand side? A 6x. It's quadratic. We're going to have to get it set equal to 0.
And you know that caused the x squared.
Yeah, it's because of that x squared, we're going to have to get it set equal to 0. And what did you say, do?
We need to subtract the 6.
Okay, so we're getting this 0 on the right side. We don't want to move this 6x squared to the other side because that positive 6 would become a negative 6. So we're going to subtract 6x from both sides. I'm doing that rather than the little universal move over. It accomplishes the same thing. So we have a 6x squared, 5x minus 6x gives us minus 5 is equal to 0.
Negative x or minus 1x, whatever you want to write on that middle term.
Okay. 6 minus 5 is what? 6 minus 5 is 1. What's that coefficient right there in front of that x?
Yeah, that's sort of like writing that 1 there.
Yeah, that's a minus 1x. I think for 2x squared, instead of trying,
for
6x squared, instead of trying 2x and 3x, I'm going to first try 1x and 6x. And once again, this is just my years of experience at factoring. Sometimes I can get it done fast. Sometimes
Sometimes you overlook something obvious, like 8 times 15.
Yeah. For 5, that's nice. There's only one pair of positive integers, 1 and 5. What do we know about the signs inside here? 1 plus and 1 minus. I'm not going to put the 5 there. Because if I put the 5 there, 5 times 6, that's 30. You're getting way far away from what you need. So I'm going to put the 1 there, the 5 there, and what do y'all think I need here with the x and the 1? Is it an x plus 1 or an x minus 1? Minus and then plus, let's check. What's the outer product?
5x.
X times 5 is 5x. What's the inner product?
Negative 6x.
Negative 1 times 6 is a negative 6x. 5x minus 6x is a negative 1x. Is that what we needed?
Yes.
Yes, it is.
Almost done.
So set x minus 1 equal to 0. Set 6x plus 5 equal to 0. This says x is equal to, here, 1. And notice I'm boxing in the answer. I don't have to check. It was an odd index. Here, that says 6x equals, well, I guess it says 6x equals negative 5. Divide, you were cutting to the chase to get a negative 5, 6. For my second solution.
1 and negative 5 over 6. 1, comma, negative 5 over 6. And I think 13 is like that one. Only a little. Oh no. Should we
13.
do that?
What's 14?
14 is like that one we just.
Oh, let's do 14
Yeah.
first.
Okay. 15 is just a quadratic formula problem. I got tired of finding radical problems, so I try to make sure every assignment has 15 problems. Most of them do, anyway. And so this one right here, you need to remind them of something.
I'm going to. But let me write it down.
Oh, you're going to write it down without telling them what a fractional exponent? Okay.
Okay, you're right.
No, you're right.
No. Okay, let's see.
I claim number 14 is very much like number 12, only easier.
Let me do it right. Oh, I'm trying to conserve paper. Oh, I got to stop hitting that speaker. It's driving me crazy.
Microphone.
Oh, microphone.
Okay.
There.
You'll have to see the little, there's a fractional 1/3 exponent here. That's what that right there is. That's another way of writing cube root. Tim,
A fractional exponent is just another way of expressing a radical. A square root of x is the same thing as x to the 1/2. And following that logic, a cube root of x is the same thing as x to the 1/3. And in general, and if you think about it, a fractional exponent, it can't mean normally, well, x squared means x times x. Well, 1/3 is an accounting number. You can't write out 1/3 factors of x. A fractional exponent is just another way of expressing a radical. In general, the nth root of x is the same thing as x to the 1/n.
So when you see that 1/3 exponent here,
On number 14,
that's really just cube root minus cube root. So you write it like this first.
well, let me write it down, Tom.
Uh-huh.
So we have, are you sure that's what,
Oh.
I didn't miscopy something?
Let me
Let me
see.
check. 4x plus 6 to the 1/3 minus 7x minus 1 to the 1/3 is equal to 0. Okay. My advice to you, when you see an equation containing fractional exponents, rewrite it using a radical. A 1/3 exponent is the same thing as a cube root. So if a cube root of 4x plus 6 minus a cube root of 7x minus 1 is equal to 0. And I think this looks a lot better than, or it looks familiar to us at least, because we know what we're going to have to do. Since it's a radical equation, we're ultimately going to have to cube both sides. But before we cube both sides, what do we need to do?
Isolate.
We have to isolate a radical. The smart thing to do is to pick up the second radical, move it over to the right-hand side, because that negative will then become positive. So we have the cube root of 4x plus 6 is equal to the cube root of 7x minus 1. I think this will probably be the easiest one we've done all day.
It's like number 12, except you're not going to have to do any factoring.
We cube both sides. What happens when you cube the cube root? That gives us
Just 4x.
4x plus 6 equals 7x minus 1. Are we going to have to get this set equal to 0 and factor?
No, there's
Because
no x squared.
No x squared, so we're not going to have to try to factor. We just isolate the variables. I think I'll isolate in a way so that I decrease the number of negatives. Move the 4x over. 7x minus 4x gives me 3x.
Take the little universe.
There. Move the 1 over. 6 plus 1 gives me. And then divide by 3 to give us x equals 7 over 3. And notice we don't have to check our answers. We had an odd index, so we raised both sides of the equation to an odd power. For a final answer of 7 over 3.
So the next problem, 15, is just a quadratic formula problem for you to practice with. Real quickly,
Now I'm going to do number 13.
I
Let's
know
go
y'all
one,
are wanting to go. So it's the 4th root of x minus 15 equals 2. Here the radicals already isolated.
So we'll raise both sides to the 4th power.
Yeah, since it's a 4th root, this is the only one where you're using a 4th power.
The left side reduces very nicely. The 4th root cancels out, the 4th power cancels out the 4th root to give us just x minus 15. 2 to the 4th is 16. 2 times 2 times 2 times 2. Add 15 to give us x equals 31. But this is a even power, so we should check our answers. That's real painless. We already had that isolated form. Plug in the 31. 31 minus 15, that's 16. Does the 4th root of 16 equal 2? That's the question. What number can you raise to the 4th power to give you 16? Is it 2?
Yeah.
So 31 checks.
So 13, 14, it ends on a light note. It's been sort of a heavy class meeting. What did we say the answer is?
31.
31. Okay. And
Any questions?
oh gosh.
Yeah.
Well, it's any questions? Now again, number 15 is just you're going to start seeing what I call review problems. If the assignment isn't long enough, I'll fill it up with review problems.
He just means an
15
old
problems.
homework material. That's what he's looking at. So
I'm going to go ahead and stop the recording. This will be the long